So let's sort of start with this idea that modern human thinking, modern cognition, began in Europe about 40,000 years ago. I mean, that's the classic textbook version, right? You get all these amazing cave paintings and elaborate tools showing up, and it's tempting to point to that as the turning point. But here's where the story gets messier. Finds in places like Blombos Cave, down in South Africa, reveal that complex thinking and artistic expression weren't just a European thing, and they didn't magically appear overnight. In fact, humans were making astonishingly sophisticated tools and engraved ochre in Africa well before that 40,000-year mark. We're talking things like those beautifully crafted wooden spears found at Schöningen, Germany, and stone-tipped weapons dating back hundreds of thousands of years, significantly earlier than previously thought. What starts to emerge, and this is where I always get a bit fascinated, is that the archaeological record is, well, patchy. Like, you see little bursts of innovation here, then long stretches where not much seems to happen. If it was just about having the right brains, you'd expect things to unfold in a smoother way, but it's anything but. It's a bit like, well, like baking. Everyone's got the ingredients, but not every kitchen ends up with a 3-tier showstopper. Why is that? Clearly, cognitive factors alone can't explain all this unevenness. Instead, the really interesting part is how brain power interacts with other stuff. Population size, culture, the environment, the whole package. And this makes me think of a fieldwork project I did years ago, actually. You'd see one group holding tight to old traditions, never really changing, while another, just a bit bigger, suddenly starts experimenting, adapting, even introducing new rituals. It's the classic ratchet effect. When a group's big and interconnected enough, you get this compounding effect. New ideas stick, get improved, and don't just disappear if one person forgets them, but in smaller, isolated groups. Traditions just sort of fade out. It really drove home for me that cultural flourishing isn't just about brain power. It needs a kind of social critical mass too. So, if both Neanderthals and humans had brains built for complicated thinking, why are those moments of artistic or technological creativity so uneven? Why do they sometimes just fizzle? The answer, or at least part of it, lies in how social networks, learning, and population dynamics all work together, sometimes sparking bursts of innovation, sometimes letting skills die out. And that sets the stage for everything else we'll dig into today. Right, so building on that, what really comes up in the research is the sheer importance of population. Not just how many people are around, but how densely they're packed together, how much they interact. I mean, the more people you're rubbing elbows with, the more chances you have to see, share, and, crucially, copy what others are doing. And that's the seedbed for those big bursts of cultural innovation we see sometimes in the archaeological record. High population density shifts the balance from simply learning by rote from your parents, what anthropologists call vertical transmission, to more horizontal learning, friends, neighbours, other groups. That's when you get real momentum. And the impact is huge. Studies show that in these situations, people don't just hang on to a tradition. They start tinkering, inventing, improving. But there's a catch. In small groups, isolated by geography or circumstance, traditions tend to ossify, and skills can even be lost entirely over generations. There's just not enough fresh input or social reinforcement. This is where humans are, I think, quite special. It's not just that we copy, it's the way we copy. We have something scholars call high-fidelity imitation. where a child isn't just aiming for the same end goal, but will obsessively replicate each tiny move an adult makes, even the seemingly pointless ones. It's weird, but it's essential. It keeps traditions stable and cuts down on mistakes when passing stuff along. Then, just to keep things interesting, we also add flexibility. This theory of mind-based ability to tweak, to understand why something works and play around with it, and to adapt when things don't work out as expected. Whenever the environment gets rough, if your population is big enough, someone usually figures out a clever solution. If others can see that and quickly copy it, maybe even refine it, a new technique, a tool, an art form, then suddenly you get what's called the ratchet effect. Innovations build up instead of falling apart. That's what happened in some of those kinds of densely populated sites, where suddenly you see leaps, like new styles of blades, or early signs of symbolic art. Whereas if you're part of a small, scattered group, you're more likely to keep the old traditions and lose the edge, literally and figuratively. So, this whole picture, it makes you see just how much more goes into innovation than any one person's genius. It's really about the whole web of copying, sharing, and refining, plus having enough people around to make it work. Now, let's dig into what's actually happening in the brain, because this is just brain food for anyone a bit nerdy. So both Neanderthals and humans had mirror neuron systems, which basically let you watch someone do something, and your brain fires as if you're doing it yourself. But humans took this to a whole other level. We don't just copy actions, we can imitate pantomimes, imagine actions without objects, and, crucially, use theory of mind to see from someone else's perspective, even when it's abstract or out of the here and now. It's really this extra layer, this integration between high-fidelity mimicking and flexible strategic copying that's unique. In Neanderthals, from what we can see in their brain structure, these systems weren't quite as interconnected or extensive. They could make tools and carved some symbolic objects, but when you compare the archaeological records, you just don't see the same explosion of variety or complexity that shows up with anatomically modern humans, especially as groups grew larger and more connected. There's actually this wonderful case study about bow and arrow technology. So, early Homo sapiens in Africa developed bows and arrows, difficult, complex, multi-stage bits of kit. But in all the Neanderthal sites, nothing like this appears, even when their brains were just as big. And here's where it gets really interesting. Children in human groups had a longer period of development, more years to play, learn, imitate, and mess about, which gave them more time to pick up these intricate skills before adulthood. That's something Neanderthals, with shorter childhoods, just didn't have in quite the same way. When you put it all together, it looks like the real difference isn't just smarter brains, but the social ability. Larger, tighter social groups, extended periods of learning, and, yes, those uniquely human copying talents. You get this interplay of brain, environment, and society that sets the stage for the incredible explosion of art and technology we see in our own lineage. And, there's still so much more to uncover. But that's probably enough brain food for today. Thanks for listening.